Good morning, my name is Mason Duffy. This is my week 1 assignment for the Introduction of Ammunition and Basic Ballistics. Today's date is August 20th, 2023. So my understanding of the 4 steps of ballistics is first, there's internal, which is the study of a projectile inside the firearm before leaving. Then there's transitional, which is the study of the projectile once it's left the muzzle. Then there's external, which is the study of the projectile once it's in flight. And then terminal, which is the study of the projectile during impact. When researching, I found that Banaras Hindu University described something that could alter the flight from internal ballistics would be a dirty barrel. This got gunked up rifling. Could lead to an underwhelming amount of spin being imparted on the projectile or even incorrect amounts of spin. During transitional ballistics, I found that a muzzle device cut at a non-square angle could lead to one side of the bullet leaving the barrel prematurely, which I thought was quite interesting because I had no clue that something that small could make that big of a difference. External ballistics could also be altered in the case of like heavy winds or unaccounted for objects entering the flight path. I found that Hornady defines terminal ballistics in layman's terms as energy on its target. I think bullet design is the main factor in the alternation of terminal ballistics, basically. Just the way that a bullet's designed and what it's meant for is going to be your biggest alteration. Depending on the design of the bullet, the outcome, it could change the form of ballistics drastically. Part 2 was sectional density. Sectional density is technically the weight in pounds of the bullet divided by its diameter. It's often referred to as stopping power, and a lot of times the NRA describes it as how heavy and long the projectile is regardless of its shape. And it's kind of explained like the higher the sectional density, the more the stopping power. For part 3, I chose question number 4, and I had to do a lot of digging on this one. It was how might air resistance interact with the rifling grooves that are pressed into the projectile from the rifling in the bore. I found a site that I will put in the description below that the Georgia Bureau of Investigations used. They said when a weapon is fired, these lands and grooves inside the barrel cut into the bullet, putting spin on it as it travels through the firearm. So basically, the rifling inside of a barrel will actually cut grooves into a projectile as it's coming out of the barrel. I called a friend who's actually a gunsmith and I asked him about this one and he explained it to me further. So when the bullet is coming through the barrel, it's actually the barrel's rifling is cutting grooves into the bullet and that's imparting a spin on it, and it creates this spin that's necessary for accurate flight. Because bullets have an oblong shape, spin is obviously necessary for accurate flight, but I found that if the grooves, however, had fouling or got gunked up, it could cause for inaccurate grooves to be cut into the projectile and then end up leading to an inaccurate flight path. That was my assignment for week 1.